So today's topic is based on the interrupts of 8085. Okay. So what is an interrupt? What do you mean by interrupt? So basically it's a mechanism by which the processor, which is made to transfer the control from its current program execution to the another program of more importance or higher priority. Okay. And this interrupt signal that may be given to the processor by any external peripheral device. In general, what happened, the interrupts are generated by a variety of sources, either internal or external to the processor. Now interrupts are the primary means by which the input and output devices obtained um, the services of the processor or CPU. Now the program or the routine that is executed upon interrupt is called interrupt service routine, or in short it's called ISR. Okay, interrupt service routine. The program, I repeat, the program or the routine that is executed based on the interrupt signal is called interrupt service routine, or in short it is called ISR, interrupt service routine. Now the processor, so what happened, if any ISR is to be executed, the processor that must temporarily stop its current task and execute the corresponding ISR, which relates specifically to the event or device that issues the interrupt signal. Now after execution of the interrupt service routine, the processor must return to the interrupted program. So processor have many interrupt signals, and proper identification of interrupt signals that is done internally by the processor. Now there are some key features that is found in the interrupt structure of any microprocessor, like the number of the number and also the type of interrupt signals those are available to that corresponding microprocessor is very important, as well as the address of the memory where the ISR is located for a particular interrupt signal. That address is called the interrupt vector address. Okay, and there may be so masking or unmasking feature that must be available for the interrupt signal. Now this feature allows the programmer to execute the ISR or interrupt service routine only when it is required. And also there must be some priority based on which, when the more than one interrupt signals are available, at that time priority must be selected. Okay, so there are three types of interrupts basically: vectored and non-vectored interrupts, maskable and non-maskable interrupts, and software and hardware interrupts. Okay, so interrupts are classified according to three parameters: now maskability, interrupt vector address, and the source. Maskability, interrupt vector address, and the source. So the first one is under the parameter by which it is classified according to the vector address. So what is vectored and non-vectored interrupts? Okay. Vectored interrupts have fixed interrupt vector address for that particular interrupt subroutines of different interrupt signals. Now they are useful for small system where there are few interrupt sources and the software structure is not complicated. That is called the vectored interrupts. But in case of non-vectored interrupts, it requires the interrupt vector address to be supplied by the external hardware circuit or any external device that gives the interrupt signal. Okay, So that's why it is called non-vectored interrupt. The vector address or ISR address must be given by the external hardware circuitry. Second type, that is the maskable and non-maskable interrupts. These are classified according to the parameter maskability. Maskability means mask mane dheke dewa, ignore. Okay, so maskable interrupts are those interrupts that can be blocked, that can be ignored for few second, for few minutes or hours according to the requirement, and the corresponding ISRs are not executed. If these are um, blocked, that corresponding ISR will not be executed. So this masking can be done by software method or by hardware means. Okay, that is called the maskable interrupt. I will give you the example of each one after a few slides. Next, the non-maskable interrupts. Then what is it? Non-maskable interrupts are interrupts. Those are always recognized. Okay, non-maskable interrupts cannot be ignored, cannot be blocked. Okay, so that whenever it is occurred, it must be the corresponding ISR must be executed. Third category, which is the software and hardware interrupt, it is under the parameter of uh, the source. Okay, so source may be it is coming from the internal or external. So internal means it is the software method. So software interrupts are special instructions which after execution the it transfer the control to a predefined interrupt service routine address. Okay, and these instructions are included in the program by the programmer. As so you are not familiar with software interrupts in your program, as you are all doing the practical or lab class through the simulator. But uh, if you have any chance to come to the college to perform it physically, then there is a trainer kit, and if you use that trainer kit, if you can execute your program, so that program should be executed or terminated by software instruction called RST3. Just like you have used over the simulator, the last instruction will be always HLT, halt. In the same way, for doing the program using trainer kit, you have to insert the last instruction as RST3. Okay, that is a software interrupt which is called the breakpoint interrupt, and that must be used to stop the execution of your program. So that is different between using the simulator program and using the trainer kit. Okay. So that is the one type of software interrupt. And hardware interrupts, those are available, or particularly the signals which are given to the processor for recognition as an interrupt and execution of the corresponding interrupt service routine. Okay. So these are the classification or types of interrupts. Now, interrupt handling procedure. So when an interrupt signal is recognized, the processor will have to store information about the current program before executing the corresponding ISR. Okay, then the processor checks for the interrupt request signal at the end of every instruction execution. So if the interrupt is masked, it will not be recognized until the interrupt is re-enabled, and CPU responds to a particular interrupt request by a transfer of control mm, to another program in a manner similar to a subroutine call function. Okay, so that is so you can see over here one picture where the main um, the sequence of operations that take place when an interrupt signal is recognized. So first, save the program counter. So because there is a main program, and there is another subprogram which is called the interrupt service routine. So every time it will be executed, the transfer, so control will be transferred from main program to the interrupt service routine always, and from interrupt service routine it again come to the main program, and again if it is required again go to the inter service routine to process it, and after processing the service routine again comes to the main program. So it's a process by which the interrupt signals can be processed. And to process each signal, first microprocessor needs to save the program counter content, that is address of the next instruction, and supplementary information about the current state like flag status or the register status into the stack. Then it loads the program counter with the beginning address of the ISR, because if when the main program was executed, the corresponding address must be given by the program counter. Okay, it stores the corresponding addresses by which the next instruction will be fetched. So when this program control is transferred from this position to that position, so because main program address is different from the inter service routine address, okay, these are two different programs, these addresses are not equal with this one. Okay, so when this program control is transferred from this position to the inter service routine, then the program counter again change it address so that the corresponding ISR will be executed, and what will be the next instruction address, the program counter will point to that address from which the next instruction will be fetched. So program counter is changed from your main program address to the sub program address. That's why when it is to be returned to the main program, so that main program address should be stored inside the stack, so that from the stack it retrieves the data and again uh, comes back to the main program. Okay, it gains the address and then coming to that particular main program address. So that's why the program counter is loaded with the beginning address of the ISR and start to execute it. Then we finish the ISR when the return instruction is executed, because there must be one such instruction which is called RET, return. So return to the subroutine to the main program, and return to the point in the interrupted program where execution was interrupted. So I have told you earlier that there are two types of branching operations. Okay, one branching operation, it is where the return, so main program control is not returned to the point of branching, and another method is where the program control is to be returned where it is resumed, means point of branching. Okay, so in that case, if it is not returned to the main program, that means it is not any it is not related to any call instruction, it is simply a jump instruction, JMP. If whether it is, it may be conditional or maybe unconditional, but if it needs to return to the point of branching where it was resumed, in that case return instruction should be inserted into the subprogram. So you must call that subprogram and return to the main program from the subprogram. So basically here the interrupts and stack memory, that is very important. So these are closely related, because stack is a special memory organization that operates on the last in first out principle, and the data which is stored recently is retrieved first because it is last in first out structure. Similarly, data stored in first in the stack, they are read last. So stack is a group of memory locations in RAM, only RAM. It is basically administered by a special register called the stack pointer or SP. And stack pointer register always contains the address of the top of the stack. So storing a data in the stack memory pointed to by the stack pointer is called the push operation, and reading a data from the stack is called the pop operation. Okay, so stack is used by the interrupt system of the microprocessor for implementing the subroutine call and return mechanism. passing parameters to the subroutine, etc. So when the transfer of control takes place from the interrupted program to the corresponding interrupt service routine, the program counter contained is stored in the stack, because after the execution of the ISR, the control must return to the program counter uh, content. Okay. Now to facilitate this control transfer, the stack pointer must be properly initialized to a physically available memory with sufficient memory range. Okay, and in the 8085 microprocessor, the stack memory grows towards lower addresses and so on. The stack pointer must be initialized with the highest memory address allotted for the stack operation, because we are writing the program in sequential order. Suppose I have started my program from 8000 memory location, then the next instruction will be on 8001, then 8002, 3, 4, 5. So I will go to the increasing order if I would like to process or operate some program. But if I want to store some data bytes, it will not be in that increasing order, it will be in decreasing order. So that's why the stack will be initialized always the last portion of your memory, so that it will be decremented by one and memory location will be decremented and the data will be inserted into that corresponding memory addresses. Okay, so that is the operation of stack. So basically these are there are two instructions to process the stack. One is a push, another is pop. Okay, so I will discuss it later, the stack operation. Now the interrupt sources and their vector addresses in 8085. So in Intel 8085 supports both software and hardware interrupts. So software interrupts are in the form of instructions, and hardware interrupts are applied as signals from any external device. Okay. So hardware interrupts and their priorities. So you know, all of you have familiar with the architecture of 8085 microprocessor. In the architectural block diagram, you have seen that there are 5 hardware interrupt pins are available. These are INTR, RST 5.5, RST 6.5, RST 7.5, and trap. So this was wrongly written. This will be 6.5. Okay, RST 6.5. Don't confuse with this one. 5.5, 6.5, and 7.5. Okay, so and trap, and so 5 pins of the 8085 are reserved for these 5 hardware interrupts. Now all the 5 interrupts are active high signals. Okay, this means that to apply an interrupt, a logic 1 or a high level signal should be applied at these pins. It will be stayed at this position. Now the processor checks the voltage on these pins after the execution of every instruction, and if the signal level um, on any of these 5 pins is at logic 1 and the corresponding interrupt is not masked, the processor suspends the current program execution and executes the corresponding ISR. Okay, here RST 7.5 interrupt alone is age triggered interrupt. Age triggered interrupt. Okay, age triggered means there are two types of interrupt: level triggered or age triggered. So what is age triggered? Age triggered means that a transition from logic 0 to logic 1, that will be treated as your interrupt input on the on this line. Okay, and the rising edge interrupt can be applied at any time, and this sets the flip flop inside the processor, because either set or reset will be function, and the processor checks the this flip flop every time while checking the signal level on the other hardware interrupts. Okay, so the interrupt vector addresses for these hardware interrupts, these are mainly for trap, these are uh, for uh, RST 7.5 for RST 6.5, 5.5, and INTR. Now, now among these 5 interrupts, only 4 interrupts have fixed interrupt vector addresses. Okay, what are they? Trap, RST 7.5, RST 6.5, and RST 5.5. These 4 interrupts have fixed interrupt vector address. That's why these are called vectored interrupt. That's why these are called vectored interrupt. So how many vectored interrupts are available in 8085 microprocessor? 4 vectored interrupts are available. What are they? Trap, RST 5.5, RST 6.5, and RST 7.5. Okay, INTR does not have a fixed interrupt vector address, since Intel has designed the INTR interrupt in a different manner. So when the INTR interrupt sent by an external device is recognized by the processor, it gives the mm, active low interrupt acknowledgement signal, which is called INTA bar. So if any signal is coming through the INTR, only INTA bar will be acknowledged, okay, will be enabled. So upon receiving this active low signal, what happened? The peripheral devices that issued the INTR signal should now place the machine code of the corresponding RST instruction that is to be executed by the processor on the data bus of the processor. Okay, so the processor, after issuing low INTA bar signal, reads the instruction available on the data bus and places it in the instruction register for decoding and for executing purpose. Okay, so among them, these 5 interrupts, interrupt priority decides which interrupts must be serviced when more than one interrupt is sensed by the processor. What happened if more than one interrupt pin is available? Means at a time, maybe 4 devices can send the 4 signals. Trap. So through trap pin, one signal is coming through RST 5.5, one signal is coming through RST 7.5, another signal is coming. So which one will be processed first? That is to be decided by the interrupt priority structure. As there are 5 interrupts, it is possible that more than one interrupt signal that will be applied to the processor by the peripheral device, and the priority basically indicates the order in which the interrupts must be serviced. Okay, and according to the order, the highest priority is set for trap interrupt. Trap has the highest priority. It will be processed first. Then the next priority goes for the RST 7.5, then RST 6.5, then RST 5.5, and the lowest priority have uh, this INTR. Okay, INTR has the least priority. Okay, so in addition uh, to the priorities, Intel has provided a feature using which a programmer can suppress the hardware interrupts, and this can be done by masking the interrupts. So trap is the only non-maskable interrupt. The other 4 interrupts can be masked. So how many non-maskable interrupts is available in 8085? Only one. And what is that? Trap. So trap interrupt is the only non-maskable interrupt. All other 4 interrupts are maskable interrupts. And what are they? INTR, RST 5.5, RST 6.5, RST 7.5 interrupt. These are maskable interrupt. Okay, so trap, it has the highest priority. It is a non-maskable interrupt. It's a vectored interrupt, and it is a hardware interrupt. Okay, RST 5.5, 6.5, 7.5, these are maskable interrupts, vectored interrupt, and hardware interrupts. INTR, it is the maskable interrupt, hardware interrupt, and non-vectored interrupt. Non-vectored interrupt. it has no fixed interrupt service routine address, interrupt vector address. So that vector address should be supplied by the help of some external peripheral device or external hardware circuitry along with the software instruction. Okay, it will be clear up to this much. Anyone? So these are hardware interrupt and software interrupts. You can write it down if you have pen and paper with you. That is RST0 to RST7, all in capital letter. You can write it down as RST0, RST. This RST, RST, RST. Full form of RST is restart. Okay, it is restart interrupt. Restart. Don't confuse with this term. It is not reset. It is restart. Is it clear? Okay, so software interrupts are available as RST0, RST1, RST2, RST3, RST4, RST5, RST6, and RST7. These 8 software interrupts are available. These are all 1 byte instruction that that make the processor execute a subroutine at predefined locations. Okay, okay, is it clear? Any queries? So that is the use for serial IO control. If SOD line, that is for serial output data, and SID, that is serial input data. So SOD is used with this SIM instruction, and this uh, if this is available for SIM, if the serial output data is available, to make it enable, this bit should be enabled because it is the master control for the serial data transmission technique, and that's why it is called serial data enable. So to enable the serial operation, this bit should be 1. Otherwise, if it is 0, then whatever be your status of this bit, this will be ignored. Is it clear? That is the SIM instruction. Any confusion regarding this SIM instruction? Any question?
Sir, application.
To 3 functions. First function is to make the mask, to use it for masking or unmasking the lower 3 bits, means the 3 hardware RST interrupts. So RST 5.5 can be masked or unmasked, RST 6.5 can be masked or unmasked, or RST 7.5 can be masked or unmasked. Okay, that means by using software method, you can ignore the interrupt signal. Okay, so masking operation or unmasking operation, basically to set for masking. That's why it is called the set interrupt mask. SIM, the full form of SIM is set interrupt mask. So interrupt can be masking can be set among 3 interrupts: RST 5.5, RST 6.5, or RST 7.5. That is the function number 1. Function number 2, it can be used to reset the RST 7.5 interrupt. Now, if this bit is 1, always this will be disabled. If this bit is 0, this may be enabled, may be disabled. Okay, so there is a master control for RST 7.5 interrupt. That is the second function. Third function is to transmit the serial data. Transmit the serial data using SOD. This bit. Is it clear? So same instruction has three function. First is to mask or unmask the RST 5.5 or 6.5 or 7. RST 7.5 interrupts. Second function is to reset the RST 7.5 interrupt with this one. So it requires additional hardware for selecting the so interfacing of INT and interrupt with the 8085 that can be processed using some additional hardware for selecting the interrupt vector address. And when an external peripheral device, it issues an INTR request to the 8085, the processor. After sensing the INTR interrupt, issues an active low INTA bar pulse. Okay, INTA bar signal. It then reads the instruction available on the data bus and places it in the instruction register for decoding purpose and executing purpose. So here the hardware uh, one diagram is given, where the instruction RST7 with the machine code EF with the machine code EF being given to the data bus when low INTA bar pulse is activated. Okay, it's given out by the processor. So upon receiving the opcode EF, the processor calls the subroutine at the address 0038 memory location. Okay, and it executes the corresponding ISR, and when it is over, it comes back to the main program to process the next instruction if it any if it is required to execute it. So that's all for interrupt. Okay, one thing I need to share with you. Okay, so to calculate the vector address of any interrupt, suppose RST RST 0 is there. This software interrupt RST 0. So what will be the vector address of RST 0? So the formula is vector address. Vector address is equal to the number of interrupt into 8. Okay, that is the formula, number of interrupt into 8. So what does it mean? The meaning of this one is number of interrupt means whether it is 0 or 1 or 2 or 3 or 4 or 5 or 6 or 5.5 or 6.5 or 7.5. So these are the numbers. So number of interrupt for this RST0 is 0. So if it is 0, so 0 into 8, how much? 0. So what is calculated over here? That is in decimal form. That is in decimal form, and this is the lower 8 bit of the memory address. Lower 8 bit of the memory address. So decimal 0 is represented, if it is converted into hexadecimal, then it will be remain same 0, and this is the lower 8 bit, that means 00. Okay, and upper 8 bit will be same for all interrupt, that is 00. Upper 8 bit same for all, that is 00. And now from this calculation we are getting this 00. So what is the address of RST00? RST0, the vector address for RST0 is 0000. Clear? What will be the address for RST1? 1 into 8, that is 8. Now decimal 8 is represented by 8-bit hexadecimal is 08. So lower 8 bit will be 08 and upper 8 bit will be fixed 00. So 0008 will be the vector address for RST1. And for RST2, 2 into 8, 16. 16, that is in decimal. If it is converted to hexadecimal, then what is that? 10. 10. So 10 will be the lower 8 bit and upper 8 bit 8 bits are fixed, that is 00. So 0010 will be the vector address for RST2. Now now tell me, what will be the address for RST5? Anyone? What will be the address for RST5?
Sir, 0005.
No. Anyone else? এই ফর্মুলাতে যেটা বেরোচ্ছে that is in decimal system, decimal number system. So this decimal should be converted into hexadecimal, and that will be your lower 8 bit of this address. And upper 8 bit will be fixed, that is for all interrupt it will be 00. So by the combinations of this lower 8 bit and upper 8 bit, it creates 16 bit address. So tell me what will be the address for RST5 interrupt?
Sir, 01000000.
No, এত মেমরি অ্যাড্রেস কত বিটের হয়? 16 বিটের।
Sir, 0029H.
29 কেন? Why it is 9? জিরো জিরো টু নাইন যে বললে, who said this? 0029.
Sir, I Sudhir Mar.
Okay, so can you tell me how can you calculate this as a 0029? I have asked you about RST5.
At first,
So what will be the number of
Sir,
interrupt?
sir, 40. Number of interrupts is
5.
5.
5.
So vector address will be 40.
40, but that is in decimal.
Yes.
You have to convert it into hexadecimal. So in hexadecimal,
Yes, sir.
what will be the value? You just divide it
Sir,
by 16.
Divide.
Divide by 16.
Yes, sir.
So 40 divided by 16. What is that?
32 plus. Sorry. 3.
That means 2 is the quotient and 8 is
2.
the
2.
remainder.
Yes, sir. 2.
Yes.
Yes, sir.
So
Yes.
what will be the value? 28. So lower 8 bit will be 28 and upper 8 bit will be 00. So it will be 0028. Is it okay? Is it clear?
Yes, sir. Yes.
Okay, and tell me, so what will be the vector address for RST7? Vector address for RST7.
Sir, 56.
56, that is in decimal.
Sir, 38. Sir, 38.
Yes, so 38. So what will be the total address? 16 bit in size.
003
0038. Is it clear?
38H.
0038.
0038H. Okay. Now can you tell me what will be the address for RST 6.5? RST 6.5. You should try this. All of you should try this. No problem whether it's right or wrong, but we have to try it. RST 6.5, the vector address.
এখানে 34 মনে হচ্ছে।
হ্যাঁ, তো অ্যাড্রেসটা বলো টোটাল 16 বিটের অ্যাড্রেসটা 16 বিট হিসেবে বলো। সিক্সটিন বিট অ্যাড্রেসটা বলো।
স্যার 0034।
0034, good. Is there anyone? যে বুঝতে পারছো না এরকম কেউ আছো?